Good afternoon, sir.
Yeah, good afternoon. How are you?
Hi, sir.
Yeah. Where's everybody now? You guys have started your exam, Abi? AJ.
Sir, yes, sir. We've started. I think we started. We finished in class. The rest have to take home. So we are like basically done, sort of.
Where did we stop last? Where did we stop last? Yeah. What was the last thing we did now? We have forgotten.
We talked about writing codes for formulas. We discussed like defining formulas, area of triangle,
Oh, okay.
some
Function.
parameters we wrote. As in interest, defining interest,
Functions,
principal
right?
terms. Yeah, functions, yes, functions. Yes.
Yeah. Sorry. So we have looked at list, we have looked at list comprehension, we have looked at for loops, right? That's while loop. I don't know that we'll touch while loop, but we have looked at for loops. Okay, list and list comprehension. I hope those list methods, I hope you still remember them. List methods. Do you remember list methods?
I think so. Is
List
yes,
comprehension.
we can use range, we can use
Range is not a list method now. All those append, what do you have again? Append, pop, remove. So all those are the lists, your list methods now.
okay, I'm not sure about this one.
It seems we are not practicing. We are not practicing. We are not practicing. Because why this is very important is that most time when you see your data will be in a list, right? It's from this list that you now convert to a data frame. So if sometimes you don't understand how to use a list, either you are using a list or a dictionary. Okay. But remember, we are learning this as data analysts. Okay. So it's very important that you understand how to work with a list and how to work with a dictionary. Just like let's give an example. Example can we give now? Okay, I think which one do we use? Let's say we have names, right? Let's say we have names. Let's say we have Francis. We have IJ. You have Buki. Okay, let's just say these three names, right? So it means if I want to add a name to it now, what do I do? If I want to add a new name to this.
Names.append.
Names dot what?
Append.
Dot append. Okay. Append which name now?
Mary. Any name, maybe Rufus or something.
Rufus. Okay. So if I say names You can see Rufus now has appeared. Now, but if I want to add another name, because this append always takes it to the last, right? So it means if I want to bring a name to maybe to a particular position, what do I now use?
We need to define where the index number that we want to put it.
Yes. So let's say we want to put it maybe the first before Francis now. I want to put a new name before Francis.
The index will be 0.
Okay. So names dot what now? What method are we using? Is it the same append?
It's not append.
So it's going to be what? Yes. Insert, exactly. Yes. Okay, insert. Insert, right? So what's the say the index is 0, right? So let us insert what now? So which name are we inserting now? Chooks. Insert Chooks. So I see names. So can we now see Chooks here now? Assuming I want to remove Rufus, how do I remove Rufus?
Names of pop. Pop.
Pop, exactly. I'll use word pop. Now, these names, are they arranged alphabetically? Are they arranged properly? So it means that you can sort them, is it not? So names dot sort. Right? So names. Are they arranged properly now?
Yes.
So we have the sort, isn't it? So if I want to remove the last one, say names dot what? Pop. Pop means what?
You remove the last opposite of append.
Yes, remove the line, exactly the opposite of append. Yes, so it has removed Rufus. Can you see that? But if you want to remove a particular one now, what do you now use?
Delete.
Okay, delete. Yes, delete. So how do I do it now? Delete what now?
No, it's names dot. Names dot.
Names dot. Okay. Names dot. So I want to remove Francis now. How do I remove Francis?
Not sure if it's delete, so but I should know it to be 0 slash. Oh, sorry, Francis, that's 1, 2, 0, 1, 2. That's 2. That's it. Names dot.
Names dot. Just remove Francis. Right? So those are just the basic things that we need to really understand. So for example, if I say names dot count, right? What am I counting now? Names dot Count. You want to count how many this thing they are there? What will I use? Let's see. Values slash. If I want to count, how else can I count? I want to do a count.
So, okay, len tells us the number of
len, right?
alphabet.
So I can use len of names. Good. Isn't it? But names dot count should have some parameters. So if I want to use a method to count, so how do we do that now? How do you count the elements in a list? Yes. So how do you count the elements in a list? So if I say names dot count, saying I don't know what you're saying. Takes exactly one argument. So which argument are you taking now?
So I thought this one counts like how many chooks are in the list or how many bookies.
So if I say count what now? Count Francis. I don't know which Francis you're talking about. Count IJ. I can only see one IJ. Can you see that? So if I have maybe where is that? Let's say I have another. Let me go to the original. Let's say I have another IJ here now. If I say count IJ, so can you see that you have to now specify? But this len just counts the number there. But this one is to count the specific. You see the difference now? Can we see the difference now between the count and the len? Okay. Then we also showed you some other words, right? Upper, lower, title. So we showed you quite a lot of the methods, especially for strings too. All right, so that's about lists, right? Then we talked about you understand the loops now, right? We understand loops now.
Yes, sir, doctor. Yes, sir.
So if I say for I in names, isn't it? Print, let's say I. So to just list all the names for you, isn't it? If we have a number, you can simply apply certain functions or formulas to them. Then those ones will work. Okay, then we talked about a formula, right? We talked about formulas. Another thing again we're talking about was something of list comprehension, isn't it? So let's say, for example, I have numbers. Which numbers do I use now? Okay, let's say list range. What? List range 1 to 21, right? So if I have numbers here, so that is the 1 to 20, isn't it? So I have 1 to 20 there. Okay. So if I wanted to multiply everything by 2, multiply through by 2, it means the same thing as saying 1 times 2, is it not? Is it 1 times 2, isn't it? 2 times 2, 3 times 2. So everything I have to go through 1 by 1. So how do I do that? I want to multiply through by 2. So how do I do that?
For I in numbers.
I in what? Numbers, yes.
I times print I times 2.
Print I times 2, right? So it will show me everything here. Okay. Now another way again of still doing it is for I in numbers. Now I can say I can put A is equals to I times 2. Right? Return A. Now what is this A now? Say return A, say return outside function. What does that mean? Say return outside function. What does this one mean now? Okay, if we run it this way now, let's if I say A, say A is 40. Why is that so? Yes.
I don't know, but for some reason it seems to be picking only the last number.
It's picking only the last number, but what do we want to do? We want to see everything inside a variable, isn't it?
Yes.
And that is where your least comprehension now comes in. Okay, so if I want to put everything inside just one variable. Okay, so I can just simply say A is equal to, then what I wanted to do was I times what? I times 2, isn't it? But remember, because it's going to be a list, so I have to now put it inside the square bracket. So if that's what I want to do, okay. So I'll say for I in what? Range what? 1 to what? 21. Is that it? So if I call A, so I'll have everything in the list. So this is called what? A list comprehension. So you can do it this way, but this one just means show me. But now I want these things to be in a variable. So then I now use what? The list word comprehension. Did you get that?
Yes, sir.
Is that clear?
Yes, sir.
Okay. Because you are going to be applying all these things much later.
Okay, sir.
All right, then we talked about functions, isn't it? Where you can write your own functions. There are some other functions that are already there, that are already inbuilt in Python. Okay. So let's look at it. And when you are writing your own function, you must first of all define the name of your function. And include the parameters. Okay. So the parameter is like, say, how many variables do you need, or how many things you need to be there. So you can have 1, 2, 3. In fact, you can have no parameter, 1 parameter, 2 parameters, 3 parameters to even 100 parameters. Okay. So you must first of all define the name of your function. So that's why we always start with diff. Define, isn't it? Define. If I say define hello, right? I say print hello Francis, right? So if I want to call the function, what's the name of the function?
Hello.
Hello. So you see, every function we have what you just open what the brackets. Do I have any parameter there? Is there any parameter?
Yes, hello, Francis.
Parameter. Is there any parameter?
It's just a string that is there.
Is there any parameter? Is there any parameter here?
No.
No parameter, right?
Yes.
Okay. So you see anything, if there's nothing inside this hello, right? See this one? That means there's no parameter there. So if I run this, it will now tell me what? Hello, Francis. Isn't it? But if I now say define hello, and now put X, and now say print, let's say hello, right? Print hello, hello what? X, right? You are welcome to data analytics club. Now, can you see that now? You notice that here you must type the person's name, right? The name is already predefined for you. Okay. But here it's not what's defined. So if I say hello and I put open brackets, right? Do we have a parameter here?
Yes.
How many parameters do we have?
One.
One, isn't it? So if I run that, you say hello is missing. So inside this, so when you are defining this now, right? So watch this now. Let's say this hello, right? So this is I want hello, right? Then this is a parameter here. Then I can also put this, so you can say hello, whatever variable name you have here, then to print that out. Okay, which means that this hello here, this is a parameter. But when I call the function now, the name I will enter here is called an argument. Do you see that? When you are defining it here, this X here is your what? Parameter. But when I call the function now to run it, what I'm going to put here is called what? An argument. So can you see the difference between a parameter and an argument? They are telling you the same thing, but in different places. So at this point where you are defining, it's called what? A parameter. But when you call the functions to now enter whatever you have, it's now called what? An argument. Okay. So if I say hello, Francis, I still say hello, X. Hey. Okay, let's say hello and run hello alone. They're still missing one parameter. Okay, hello, what now? Hello. So why did Francis not go? Say hello, Francis. Say hello, X. So what's the issue then? What if we put this here? Will that also work? No, it doesn't. So why is not seeing Francis there? But if you just run hello, so this one tells you that is what? So this is it's telling that is what? A function, isn't it? So why is it not showing me hello Francis? Yeah. And saying Francis is not defined. Can you see the difference now? You see what happened?
Yeah,
You
what
know normally
inverted comma?
Just
yes, you know normally when we use the to enter a string, right? Let me run this again. Let's say hello IJ. Hello IJ, you are welcome to Data Analytics World Club. Okay. But if I have used double quotation normally, it should still work now. It should still work. Anyway, but this is no parameter. This is what one parameter, right? Now, when you now have your normal formulas, where you now have to enter a series of numbers or what have you. Like which example did we give? Okay, let's say define. Let's say you want to add up two numbers. Let's say define a comma b. So it means here I want to add up, isn't it? So x is equals to, let's say, a times b plus e, right? Then I say return x. You understand this? Now remember, don't use this word sum like this, because remember, sum is a reserved word. Let's say sum values. Okay, sum values. Okay. Do you understand what's happening here now?
yes, sir.
So define the name of the form. What's the name of the function now? What is the name of the function?
Some values.
The name of the function is sum what values. How many parameters does it have?
Yeah.
2 parameters, isn't it? Then this is your expression, right? Or your formula that you're putting there. Inside this variable. This x is called what? This x is called what? What is x called?
The local variable.
It's called a local word variable. Exactly. It's called what? A local word variable. Can we differentiate between a global variable from a local variable? Can we differentiate a local variable from a global variable? Can we differentiate a local variable from a global variable?
I think a local variable works just within a something you're trying to define, but a global variable even outside that line, it still functions.
Yes, that means I can call it anywhere. For example, A here is what? This A is what? A here is what?
It's a list of numbers.
Yes, that's the content now, but what is A itself?
It's a variable.
It's a variable. Which variable now?
A global variable.
It's a global variable, so I can call a global variable anywhere. But this X is what?
Local.
It's local. If I put X, it doesn't know what you're saying. Can you see that? So for global variable, you can call it anywhere, but for local variable, you can only call it within the context of this function. This is the difference now. That one is local. Okay. So now if I want to add up, let's say, so some values. So what are the arguments now? Then remember, you have to put a string function, right? Remember a string function so that you can define what's happening here. What is sum of how would we describe it? I say multiply two values and add the first value. Okay. So remember, anytime I call these sum values, right? I call sum values. Can you see that? Now, if I press Shift Tab, can I see the name of the function now? Can you see that? It will now describe what you are doing here. So remember, this is called what? A docstring. A docstring, okay? So how many arguments do you have here now? How many arguments do we have in this function? Two. What are they?
A and B.
A and B. So if I have A as 10, B as 5. So what do I expect to be my final value?
10 times 5 plus 10. 10 times 5, 50 plus 10, 60.
60. Is it 60?
Yes, sir.
All right, good. Okay, so it means that I can add and call any value there. So some values, I can put 3,1. Can you see that? So you can call any value there, right? So this is for what? Two functions, isn't it? We showed for three functions. For example, we talked about which other one? So define interest. Let's say interest. Let's say interest there. So we have principal times rate times time. Okay. So here we can just put a simple docstring. Okay. So I have interest. let me just say interest is equals to what now? Principal times rate times time, isn't it? Say return what now? Interest. Now, unexpected indent. What does this error mean? Unexpected indents. What does this mean?
I think that's it shifted. It's not supposed to shift.
Yes, because everything is within this, right? Unexpected indents. So let me take this guy off so you see what's happening there. Can you see what has happened? So normally, if I come here, can you see how it's supposed to be? Can you see how it's supposed to look like? This will run, isn't it? So the moment you move this, can you see what's happening? So anytime you hear indentation, indentation means what? Indentation means what? When you hear indentation, what does that mean? Eh? Yes, space or let's say paragraph, more like paragraph.
So sir, that means that means in Python, like the space matters, like where the thing is, where the code is written.
Especially when you're defining the function. Especially when you're defining the function, yes, it matters. Yes, spacing, yeah. Okay. So if I have interest, now always be careful so that I don't use the same name all through. So that I don't have the same interest and I'm calling it interest as the variable there. So how many arguments do we have now?
3.
3, isn't it? So if I have 3, then let's say I have 1,000. I have, let's say 0.1, and let's say for 5 years. So if I do the calculation, isn't it? Then we have that there. Okay. So that's basically about your function. We can get as complex as you want. Then I also showed you that sometimes you can also predefine the particular value if you want there. So for example, I think we gave one example. Which example did we give last time? Anyway, you can just specify a particular number. Let's say, for example, where was that our sum values? Okay, let's say define A. Let's say we put 2 values there. Let's say we have 2 values here. Let's say I have X and Y. But this my Y, I want this my Y to be 10. See, by default, this Y is already what? 10. Okay, so what do I want to do? Now, either I can put, let's say, I can put sum equal to, or let's say add equals to, let's say X plus Y, right? Then I'll say return what? Return what? What am I returning now? Add, isn't it? Now, if I don't want to do it this way, then what I can also do, I can have define A, let's say X comma Y equals to 10, right? Now, if I don't want to do it that way, then another thing I can do, I can just say return X plus Y. Can you see it now? So this one I can put it straight, but most times, so if I run it straight like this, it will still work. So the function name is what? A. So how many parameters do we have?
2.
2, right?
Yes. 2, yeah.
So we have X and Y. So if I put 10 here, right? If I put 10 here, it means X is what? X will be what?
$20.
X is what?
X is 10.
X is 10, isn't it? Y is already predefined. Isn't it? Y is already predefined.
Okay, so this was the issue we were trying to discuss last time when we were doing that dollar naira thing.
Yes. And what was the issue?
Okay.
Yeah, we're saying that this is already what predefined already. So in the argument, so even if I put another one, let's say I put 20 there, right? I put 20 there. So that means I have two parameters now, right? So that means that this my y now is what? This my y is now what? 20.
20.
Isn't it? But if you don't put anything already, if you don't put anything, that means you take one and add it to already the predefined one you have there. Because this is what we normally have done. Isn't it? X is 10, y is 10. But if you don't put that, he already knows that your first argument is 10, the other one is also what 10. If you add it up. Yeah?
Yes, sir.
Okay. Okay, so that is for. So let's see. There's another very important one we need to also look at. There's another important one we have to also look at. Because sometimes when you are writing functions, sometimes the functions can be so long, right? But you need to call up that function to do something else, somewhere else. Okay. So in that case, what you now do, just like we have list comprehension, right? How we have list comprehension. Okay. Now for functions, we now have what they call anonymous functions. So if I don't want to call the function anything, you know how we do it, like we say define A or define some values. Define some what values, isn't it? So that some values is the name of the function. Assuming I want to write a function, so that means I want to write this function straight without going through this process of defining the name. So this will now be called an anonymous function. Anonymous function, which we call what? Lambda. It's called what? Lambda. Have you heard of lambda?
We heard it from you, sir.
Lambda. And is it in primary school? Didn't we hear lambda in primary school?
Yeah, we did.
It's the lambda you're talking about. Lambda.
It depends on the primary school.
Okay. Or is it secondary school?
It is still primary school, depending on the time people enter primary school.
So that lambda. So that lambda now. So just like saying, so this A now. So I can call the A straight and say A equal to, then I can call lambda. And what is that? Our principal times rate times time. Which one did I use? This one. Let me call this one. So this is what you normally do for your function, isn't it? This is what you do for your function normally. Interest, okay? Now, if I want to write this function straight, right? I want to write the function straight, so I can say interest is equals to, so lambda. So what is the formula now?
Principal times rate times time.
Principal times rate times time, isn't it? Principal times rate times what? Time. Okay. what do you say? Okay, that is the function. So what are the parameters? Principal times rate times time, isn't it? Principal times rate times time. So the function will now be that, right? Good. So if I want to call it up now, what do I now call? Interest is what? Let's say what I use 1,000 0.1, then maybe 5. Can you see that? So instead of me
Yeah, so that means
writing this, I can use one line of code to do that.
we've converted that INTR from a local to a global variable.
Yes, it now becomes a global variable. Yes. But it's showing you here that this is now what if it's doing a function now. But what differentiates it now is that in this case, right, you must have defined, you cannot just call it like a normal variable. Can you see that? You must now enter the arguments there for it. So if I have 20,000 at 20% for 2 years. So what you are defining as a function, you can now quickly put it as what? A single line of code. So in case you have to do any thing, you can just define that your function in a single line of code. So first of all, you must call the name lambda. Lambda simply means an anonymous function, right? The name of the function. So any name you call it, just call it what? Lambda. Okay. What are the parameters? What is your expression? Okay, so if I type lambda, lambda, right? So if I press Ctrl Tab, you see this is a local function here because that means that it's already defined in Python. Okay, so once I call that, so those are actually functions without what? Names. So if I want to do a function to calculate 3x plus 1, I want to write a function to calculate 3x plus 1 straight. So how will I do that now?
We'll name it, we'll first name it something equal to lambda.
Okay, let's say B.
Equal to lambda x x colon 3 times x plus 1.
3 times x plus 1. Okay. So if I want to run it now, how will I run it
now? B into brackets, and now put any figure, be 5.
5. Okay. So what should I have there?
3 times 5 is 15, 10 plus 1 is 16. So it should be.
So it means that this one has how many parameters?
1 parameter.
1 parameter. So if I want 2 parameters now, how will I do that
now? Maybe 3x plus y. So that will now be like 3.
So if I want 3x plus y, you know, plus 1. So what will it now be?
Now be c is equal to lambda x comma y.
It will be what?
It's equal to lambda x comma y
lambda x comma y, okay.
Colon 3x plus y plus 1.
3 what?
3 times x
3 times x
plus y plus 1.
So if I'm now running it, I'll have what?
If we choose C brackets x as 2, y as 3, so 2 comma 3.
So what do you expect to have there?
Okay, 3 times 2, that's 6, plus 3 again, that's 9, plus 1, that's 10.
All right, so you understand that now. So you can also have 1 parameter, 2 parameters, 3 parameters. Isn't it?
Yes, sir.
And it can also, in fact, you can also have, you can even complicate it again by even putting lambda inside a function. Okay, but sometimes you can have it that way, where you now define your lambda inside a function. But anyway, that's just the basic thing about that. Are you clear with it now?
Yes, sir.
So function lambda, okay. So sometimes when you don't want to call, because sometimes you need to write, the function may be very long, but you cannot be writing the function inside a particular variable name, right? So what do you want to now do? You now have to call it inside. So it's just like if I want to call it inside this, so I can now say maybe sum, or let's say x is equals to. Can you see that now? So if I now call x now, if I say print x, can you see that now? So this I can now call it inside and that variable. So it'll be easier to do it that way. So sometimes again, just like we have our define function, right? So you want to define a particular number. So let's do this. For example, we have okay, let's say we have which one can we use? Okay, that's our principal times rate times time. Let me see which one would have been easier. Okay, let me use the area. I think area will be easier. So let's say area. Let's say you have how do you find is it the perimeter? Is it perimeter of a circle? How do you define perimeter? What is the formula for perimeter of a circle? Perimeter
2 pi r.
is what? 2
pi r.
Pi. How would I put pi down? Pi. So 2 times pi, is it not? Times r. Something like this. Right? So we have something like this, isn't it? We now know that if I was to get the, okay, let's say define. So let's say define perimeter. Perimeter. Can you see what I'm spelling? Perimeter. Is that spelling correct? Anyways, so define, let's say, perimeter. In this case now, how many parameters do we have? How many parameters
Pi
do we
is
have?
constant.
Pi is constant.
It should be 2, sha. 2. That's pi and r.
Pi and what?
Parameters. R.
So what are the 2 parameters?
R and pi is equal to something.
What is the only thing that is going to change there?
R.
It's only R that is changing, isn't it? So the only one that is changing
Yes.
is what you are going to put there. Because you said pi is constant, 2 is constant, isn't it? So the only thing that will change is what?
Is R.
It's R. So that's why you are going to put what? One parameter there. Do you get that?
Yes.
So which means in that case, so if I say area is equal to, or let's say area, should we call it area or perimeter? Okay, equals to P is equals to now 2 times pi. What do we say pi is? What is the formula for the number for pi?
3.142.
3.14, right? Times what now? Times what? R. Isn't it? Return. So return what? Return P. So it's not in it. Okay, return what? P. Okay. Now, if I want to call it up now, how will I call it up?
Perimeter brackets.
Perimeter.
Let's use 4.
Let's use 7.
7. Okay, 7. All right. So what do we now expect to get?
That's 7 times 2 times 3.142. No normal, so.
Just
14
estimate.
times.
I know that it makes sense for me.
That would be like 40 something point.
Is that it?
Yes.
So that's it, right? So imagine
Yeah.
that
Yes.
you now have, I want to now check, right? I want to check, so different values for that same parameter. So we tried at 7, we can try at 8, we can try at 10, we can try at 20. Do you get? We want to try at different levels. Okay. So maybe you have tried at 7, you want to try at 8, you want to try at 10, you want to try at 9, right? So in that case, what do we now do? So this perimeter, you want to have different values, different range of R, right? So let's say you have R, let's say we have 7, we have 8, we have 9, we have 10. So it means that we want to calculate, so let me just say, so we don't confuse ourselves. Let's say radius. You know, we calculated at 7, so we want to calculate at 8, at 9, at 10, at different levels. It's just like doing sensitivity analysis.
Yes.
Okay. So if I want to go through it now, how do I? So that you calculate. Yes.
You have to iterate through all of them. That's using that for
So how will you do that now? Exactly. So how will you do that?
For I in radius.
Right, radius. Yes.
For what?
Radius on then. So let's start that one first. Inspiration.
Okay, you say for what?
For I in radius.
Yes, for I in radius. Yes.
Print perimeter.
print perimeter I.
Print.
Okay, or just perimeter. I think if you just say perimeter I without using prints, will it go? Yes.
But let's try the print thing first now. Well, anyone, I don't know.
Like this.
Yes.
Mm-hmm.
Wrong.
That's what you're saying. No?
But you still have to print it, Sha.
So to show, right? To say print.
Okay.
Yeah. Daddy.
Oh. No wonder.
All right. So what has it done?
Has printed the radius of the perimeters for different radius, the different radii.
Now, if I want to pull all this now inside the variable, let's say call the variable area. So how will I do that?
Area is equal to.
I cannot access all this one now. So I want to put it in variable called area.
We just okay.
Area is equal to perimeter. Area is equal to perimeter I.
Okay, the perimeter. Okay, as if you want to put it in a sentence.
No, I want to put it in a variable. All this, I want to put it in a variable. Because we cannot access this now. If I want to use it to calculate again, I cannot use it to calculate anymore. Because this is just showing me the values, but it's not, I cannot have access to it. So if I want to put it in a variable, now how do I put it in a variable?
Okay.
Area is equal to. So could we do like a lambda?
I don't know what you want to do now. I want to do lambda. As the series is.
Okay.
Yes. Now remember, when we are working with this list there. Now, if you only do a lambda means that I want to just define it in one function, right? Yes, you can also use a lambda to do it. But now in the lambda, it means that I don't need to define all these things. I don't need to define all these things now. Okay. What I can do, I can put an empty list now, right? Called area. Isn't it? So I want to put everything inside this area.
Okay.
So what do I now do now?
What did you do there?
Because at the end of the day, when you are done with the computation, you need this computation to now take it somewhere else now, it's not? So further analyze.
Yes.
So that's why you must always put it in a variable.
Area is.
So for the same thing you have done now, the only difference is that I want whatever I have here, I want to put it inside this area. So I'll say for what? So let's say for R in radius. So what's formula there now for R in radius, isn't it? So what do I want to do now? I want to call let's say A is equals to what? What was our function? What was our function?
2 times 3.14 times R.
The function is what?
Perimeter.
Perimeter. Now it has perimeter. I think that's already defined now. So perimeter,
Yes.
right? Perimeter. But what we have is what? R, right?
Yes.
That's our argument, isn't it?
Yes.
Then what I want to do is now A dot what? Append. Append what?
R.
Okay, let's so that we don't have a. So this is what? What are we appending to? Is it not area?
Area dots.
Append what? A.
A.
So let us see. So we have defined this perimeter, right? Here. So hopefully you see this your perimeter there. Okay, so if I call area, can you see that? Have you seen what we have done now? Have you seen this?
Exactly. Yeah, this makes sense.
It makes sense. All right, now this is even hard work. What we have done here is even hard work. Okay. And that way again, we would have even done this, right? You have what they call, this is called map. Do they have map? Let me see, map. Yes, you have what they call map. Okay, they didn't define anything there. It's not defined there. So let's say if I say map, so we have what they call it now. So let's see. So radius. So the name of the function is what?
Perimeter.
The name of the function is what? Perimeter, isn't it? The name of the function is what? Perimeter. Okay. Why our variable is what? So the name of the function is perimeter, right? So that perimeter, we want to fill in the radius in that perimeter, isn't it? So if I say perimeter, what? Is it radius? So this is the function. This was the list. Is that? This is the function and this is the list. So let's run that and check. So if I now show a list of it, now let's see whether it will give me the list. Can you see that now? So all this I have written, I have put it in one list now. Then I can now put it inside what? Maybe area 2. Sorry, area. What's the problem here?
There's a space.
In the
So
what?
you should have put like underscore or something.
Area 2.
Also, I don't understand. What's the function of that map?
That map. So that map, what you have done here, what you are doing to iterate it now one by one, is it not? So here, that map is just saying this is the function name, is it not? What do I want to do? I want to go through it and calculate for this, calculate for this, calculate for this. So I put this one here. So this is going to iterate it through that list. So the function name, whatever I have here, I'm going to go through that one particular word list. I'll go through that particular word list. So that's what that map is actually doing for you. Let me see. There's another one we can also do for it. Okay, let's do it this way. Let's say, for example, you wanted to. Okay, let's say we have different. Let me see which type of example. What's your example can I use again that will make sense? Because I want to show you filter, how to work with filters. Because I'm just trying to show you that there are different ways. You see, the same thing we wanted to do. I've shown you like 3 different ways of doing it. There may even be more ways. You can even do a lambda straight to also do that too, right? But the point here is that rather than you going through this process, as long as you have defined it, right? Instead of me going to call it one by one now, I can just use what a map. So that mapping is just taking it as it will take this value, apply this function to it. Take this value, apply functions to it. Take this value. So it's that what they call the mapping. It's called map. Okay. But you see, to call that map now, you now have to put it inside the list so that you bring it out for you. Otherwise, if you just call it map, it just tell you that now it's in the map. It has mapped it out for you. Okay. But what you now need to do is to, okay, let's say, for example, you have temperature of, let's say we have temperature of, let's say, let me put it in a list. Let me put in a list now. So let's say you have, let's say, Nigeria. Nigeria. Let's say, what is temperature in Nigeria now? Let's say 29 or so. Let's say you have another, let's say you have Ghana. Maybe Ghana has maybe 32. Let me take another one. Let's say, which other one? Let's say we have, South Africa.
Football. 24.
South Africa. Let's say 24. Okay. So let's say we have a list here now, isn't it? We have a list. Okay. So this is another way also put in a list. You know, another way of doing this is to put it in a dictionary. So we can put it this way also. Okay. Now, what if I want to go through it now in such a way? I want to add 1 to each. Maybe I want to add 1 degree to each of them. I want to add 1 degree to each of them. Right? I want to add 1 to each of them. Okay. So in that case, you know, if I want to call this one out, so if I want to call this 29, how will I call 29? How do I call 29? If I want to call this 29, how will I call it?
As the index temp.
Yes.
Temp 0.
Temp 0. That is temp 0 for you now. But I want to call this 29. What is this 29 now? Okay, if I say temp 1. So this is 0, this is 1, this is 2. So that means that this will be 0, right? Something like this.
Yes.
Something like this. Okay. Good. Okay, let's see now. What if we define, let's say G is equal, let's say we're using A, B, C, D, E. Okay, let's say F. Okay, let me leave the G. Now I want to use lambda what now? Let's define it as X. Then we have X 1 plus 1. What would that give me? So if I say G, so it has called it in a lambda, right? Function. Will this give me the right thing? Okay, let's see. So if I say, so I want to use a map. So if I want to map it now, how do I map it now? If I want to map it now, how do I map it? So I have map what? What's the function? What's the function? Yes? The function is what? What is the function here? What's the function here?
X. So no, G.
The function is G. What is the list?
List is temp.
M. Is it not? So if I want to bring it out, say lists. So what has it done? Nigeria now will be what?
30.
Ghana will be what?
33.
33.
South Africa will be what?
25.
Can you see that now? So you must have the function, you have the list that you want to iterate through. So that's the mapping.
But how do we now put it back into that line 95?
You want to put it back
Yes.
here. You know, at this point here, right? At this point here, this was the original list that you have had. Okay. So what you'd have done again is to use, because what we are doing here is a computation, right? So if I was to now add it back here, right? So in this case now, you cannot just put it straight that way. So you have to put it in like, yeah.
So could we say temp is equal to this list map G temp, so that it now changes the temp to this? As in, is it possible for us to say in line one,
Like
in line one? No, like temp is equal to all these.
Temp is equals to this, like this.
Yeah, is equal to what we wrote before. Yes.
And so if I have temp, you get.
So that it shows in that. Okay.
Okay, let's see. So this is. It will be possible to do it, but you have to just think about how it should work. You get. So in this case now, if I want to change here now, how do I change this one now? If I want to replace this one, how do I replace this? How will I replace this now? You want to replace 29, how do I replace 29 now? Yeah, so if I have 0, 1 equal to 30, So what do you say? You say tuple object is not what? Is not what?
Not support item assignment.
So remember, what is this? This is a list, isn't it? What we have here is a list. A list of what?
Strings and
So anytime we put it here, right? So this is the list, right? Because this is a collection now. So remember that what we have here is actually what? A tuple. Because a tuple is what? So remember how we put tuples? This is how we put tuples now. So if I have A equals to 1, 2, 3, 4, 5, let's say 5. Isn't it? This is what? So if I say type A is what? A tuple. Can you see that? But if I have A is equals to 1, 2, 3, 4, 5, right? Okay, let me say B is 1, 2, 3, 4, 5, right? So if I have type B is what? A list. So for list, I can easily say B1 is what? What's B1?
2.
2, isn't it? So I want to change that 2 to 4. Or let's say I want to change it to 10. So it means if I have B, what do I have? 1, 10, 3, 4, 5. So let's come to the tuple now. So for the tuple, the same thing. A, let me run that to be sure. So A, so what is the, so for 2, I want to change that 2 to 10. So how do I change 2 to 10? How do I change 2 to 10? How do I change this 2 to 10 now?
Two plus 1. A1 is equal to 10.
Can you see that? Because a tuple is immutable. You cannot change a tuple. Do you understand that now? Because when you use a tuple is when you know that this thing you have here is permanent. You cannot change it at all. It doesn't change. That's why you use what? A tuple. But if it's something that is going to be changing, you are going to use what? A variable, a list. Sorry.
A list.
Yes, use a list, a proper list. Yes. Now I say in this case, if you do it like this, you would have also used like a dictionary. Do you understand? You can also use like what? A dictionary. Okay. So that's how you just do that. Because there's nothing you cannot do. As long as you can think about what, first of all, need to know what you want to do first. Do you get? Before you can start all those things. Because I wanted us to get into, maybe we'll just go there. I wanted us to go to NumPy and Pandas. I don't know whether we can do that today. I wanted us to get to NumPy. But so far, what we have done, this is the basics of Python, right? This is the basics of Python. Although we have looked at map, so you have some other ones like filter, reduce. Maybe later, if there any time we are going to come across it that we need to do, maybe I'll touch it again. But for now, these are the basic things that we are going to need. Okay. All we have done so far is what we have covered was the basics of our Python. So it's just for you to build on it. Just build on it and keep practicing it. But remember, we are learning this as data analysts, right? So we'll talk about the basics of Python. At least we've covered much of the things that we are going to require. Okay. So there's something else we need to enter, what we call NumPy. 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 So this NumPy is actually called, we call it numeric Python. This is like the basis of almost anything you are going to be dealing with in your data analysis. Okay. So remember all those functions we were writing before, all those functions we are defining ourselves. Okay. Now these are now what they call libraries. Okay, libraries means people have already done it now. What you now need to do, you need to bring it in. Okay. So that's why we use what? Import. So here import what? NumPy. So this NumPy is a library used for what? Carrying, so all those your arithmetic, your matrix, all the mathematics that you do, this is the basics of it. So it's called numeric what? Python. Okay, so it's just a function that carries, that has a lot of other functions inside that you use to carry out what? Arithmetic operations, matrix, and different stuff. Okay, but especially for matrix. Okay, especially for what? Matrix. Okay. So NumPy. So that's the library that most data analysts are going to use. So import NumPy. So what we do, instead of us calling it NumPy, so best practice is import NumPy as NP. So what does that mean? This NumPy will now be called what? NP. So remember in SQL, this is called what? Okay, we have not done SQL, right? So in for those who have done SQL before, what is this called? As NP, what is it called? What is this called? What is it as NP? What is this called? Yeah? What is this called? What is it as NP? What is it called? What is it IJ as class rep? Can you see that? IJ as class rep. What does this now mean? As class rep. What is this called? It's called an alias. Thank you, book. It's called what? An alias. It's called what? An alias. Alias. Yes. So instead of me calling IJ, I just say class rep. Who will answer me? Who will answer me when I call class rep?
IJ.
IJ, isn't it? So the same way, if I call MP, who will answer me?
NumPy.
NumPy, exactly. So that's why we use it. So this is the best practice. We call it, just say import NumPy as what? NP. Are you okay with that?
Dr. Francis, it means that somebody can import NumPy without using as NP.
Yes, now you can, exactly now. Now just say NumPy. So instead of you be saying NP, just be saying NumPy. Calling it When we get to machine learning, you now understand that when you see those libraries, those modules, you see they are quite lengthy.
Yeah.
You can also import, let's say NumPy. You can also import, let's say pandas like this. Can you see that? I can bring in NumPy. I can bring in pandas like this. Okay, but we'll see generally this is what we do. So import NumPy as what? NP. Import pandas as PD. Okay, so let's first start with NumPy. So let's first start with what? NumPy. And NumPy is what? Numeric what? Python. Okay. Now we see that in your basic Python, isn't it? In your basic Python, let's say we have E. Let's say we have a number. Let's say we have numbers 1, 2, 3, 4, 5. This is how we have it normally, isn't it? So if I say type,
Yes.
this is telling you that this is what?
List.
A list, isn't it? Now, you know, as data analyst, right? You are going to be working with tables, isn't it? You are going to be working with what? Tables. So far, have we seen any table in Python? Have we seen any table in Python?
No.
Have we seen any table in Python?
No, sir.
So remember, in Excel, you'd have had rows and columns to work in Python, isn't it? In Excel, that's it for Excel. But you see, in Python, there's nothing like a table now. Is there any table there?
No.
Have we seen any table since? No, okay. Now, when you are working, if you want to put it in form of a table, in mathematics, we talk of what? A matrix. Is it not? We talk of what? A matrix. And those matrix, they have what they call what? Arrays, is it not? Or we talk about the vectors. Please, do we remember our matrix? Do you remember our matrix? Not matrix movie.
We have forgotten, sir.
That's the only one we know, sir. That's the only one I know, sir.
What matrix movie? If I just when you get after this, you go and look at a matrix. But just understand that that matrix is also made up of like rows and columns. So you can talk about row 1, row 2. So I can have something like this: 1, 2, 3, 4, 5, 6. Can you see that?
Yeah.
So this is what? This is what?
Ayobami.
1 and 2 is what? 1 and 2 is what?
Like rows.
Those are the rows, is it not? A, B, C is what?
Columns.
Columns. Is this not how you have it in Excel?
Yes.
But you see, this 1, 2, 3. Is it not? This 1, 2, 3 is what? 1, 2, 3, 4, 5, 6 is what?
The matrix.
No, I'm talking in Python. We're talking in Python now. So 1, 2, 3 is what? If I put it in compound bracket, now what is this? If you have a compound bracket, 1, 2, 3.
Is it 2?
4, 5, 6. I'm using this bracket to.
Is a list.
It's a list, isn't it? So
Yes.
this is what we have been working with. This is a list. This is also what? A list, isn't it? But you see, a collection, they will call it what? An array. You know, in Excel now, when you talk about an array, what is an array? It's just a collection of what? Numbers. But when we put it in a particular shape, where it's now going to be by rows, by what? Column, isn't it? So we'll now use what? A matrix. So to get a matrix, that is why we are going to be using this what? A library, NumPy. So think about this matrix as if you are working in Excel. Okay, you're working what? In Excel. But this, what you have here so far, is just a simple what? List, isn't it? So what we need to do, we need to convert this list that we have here into what we call an array. We need to call into what? An array. And what is an array? What is an array? An array is what? Just a collection of what? Numbers. Is a collection of what? number. So we want to convert this into what? An array. Okay. So to convert it to an array, what do we now do? We call it what? NP. What does NP mean?
NumPy.
NumPy array, isn't it? What's our list? Was A, isn't it? So can you see now array now? Can you see the array?
Yes, we
It has
can.
converted to an array now. So let's assume, so this one we have 1, 2, 3, 4, 5, 6. Okay, let me say 6 here. All right, so that's the array that we have here. Okay. Now, if I was to put it in a matrix form now, how would I put it in a matrix form? Exactly what I've done here. So let's say matrix. Can you see? I'll open the first bracket, isn't it? So this one you are seeing here is that this bracket you are seeing. So to put this one now, I'll open another bracket. 1, 2, 3, comma, and that bracket again for this one now. 4, 5, 6. Can you see this now? Can you see this? What you have here is what you already have here. So that's why if I want to now put it out, so I'll say np.array matrix. Can you see what we have here now? So this is how you work as tables in Python. So this is not a table for you in your Python.
It seems as if the matrix thing is like a list within a list.
Yes, now that's what
Like
it is now.
different
That is
lists inside one big list.
Yes, that's what it is, which we call nested lists. Which we call what? Nested what? Lists. Okay, so that's a nested what? List. Are we clear with this?
Yes, sir.
We are clear? Okay, good. So going forward, it is this matrix that you are going to be thinking as Excel. So what you need to just take note is how it is what arranged. Okay, so you can easily what read it. So you are reading it what row by what column, isn't it? Now you know that in your, like in your basic Python, if I want to bring a list of numbers, say for example, say list, let's say list range 1 to, if I want to bring 1 to 9, how do I bring 1 to 9?
110.
110, is it not? So this is what I have here, isn't it? So if I call this b equals to this, right? So if I want to make it an array, what do I now do? If I want to make it an array, how do I make it an array?
np.array brackets b.
B, yeah. Array bracket B.
So that's what we have. So can you see that? Okay, now if I wanted to, so this is how we do it in Python normally, right? So where we bring the numbers, we list the numbers out. Okay, but for NumPy has its own. NumPy has its own. So you say np.arange is not arrange, arange. So 1 to what now? 1 to what now?
10.
10. 1 to 10 will give you what? Can you see the array? Now put it already in an what? Array. Because for this one, you need to now convert it, is it not, into an array to have this. But now, instead of you getting the list, they convert it to an array, Now, NumPy has its own what? Range that you can easily convert into what? And I already convert to an array for you. So it's np dot what? A range. Are you clear with that?
Yes, sir.
Yes, sir.
Are you clear with that? Good. Then you know that in your, now in the same way, you can also arrange it in such a way. For example, this one we have is so we have 1, 2, 3. So by default, it's increasing it by 1. The same way, if I have, let's say, let me say 1 to 21 by 2. Now you see what it's doing. One, so it now be 1, 3, 5. What have you? So if I say increase it by, let's say, 1. So this is giving me what? So I'm increasing it by 1, right? So if I'm going by 2, if I'm going by 3. So what do you think? What is happening here now? What is happening here?
It's only printing. It's only releasing the printing numbers that like this. If you do 2, it skips every second.
Yeah, every 2 numbers, exactly. Every 2 numbers. Okay. But in that case, if I want to make them like full numbers now, so what do I now do? So I have to now make it from 0, isn't it? So we can also do that. Then in a matrix, we also have your, in matrix, so look at another thing again. We have, for example, let's say 1, 0, 0, 0, 1, 0, 0, 0, 1. What is this called in a matrix? Where you have all the diagonal eyes. So you have all zeros. What is this called in the matrix? What is this one called in the matrix? When you have all the ones in this diagonal, what is it called? We are engineers. Ayabami, are you not an engineer?
Oga. What is identity or your name?
This is identity. It's called an identity. Why this is a word? Zero matrix.
Zero matrix, yes.
This is called a zero matrix. You can also have a situation where you have all 1, 1, 1, 1, all ones. All right. You see why, as data analysts, when we started at the beginning, we say one skill set you need to learn is what? Mathematics. Mathematics. Because somebody will be asking, okay, why do I need to learn all these things? Okay. You know, at the end of the day, what you will need to do is that after your analysis, so remember in data analytics, right? We talked about descriptive analytics, isn't it? There's diagnostic analytics.
Diagnostics.
There's predictive analytics, isn't it?
Yes.
Prescriptive. And prescriptive, exactly, and prescriptive. Okay. So for this predictive part, that means I want to predict. Okay. If I predict it happens, 1. If it doesn't happen, 0. Can you see that? If I predict that maybe this is a fraud case, non-fraud. So if I predict that it happens, 1. It doesn't happen, 0. Can you see that? So it means that in your outcome, what you are going to see, you are not going to see numbers. What you are going to see is a matrix. So you may see 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1. This is how you see the result of your data. It will come in this form, which means that anytime I see 0, what does 0 mean? Whenever I
There's
see
no
0,
fraud.
there's no fraud. Y1 means what?
It's fraud.
Y1 means there was fraud. This is not. So this is how the output of your result will come out. It's not going to come out in form of a table. It's going to come out in form of what? A matrix. Okay, so that's why it's important to go back and understand the basic matrix. But this is actually how the result is going to come out. Okay, so that's why we are going to be looking at this matrix. Are we clear? Because Python doesn't have tables. So what it will understand is what? A matrix. So a matrix is like a table in what? Programming. All right, so let's continue. Let's continue. Okay, good. All right, let's go back. Okay, so the same way, what we are having all zeros. If I have np dot zeros, let's say, let me see how many zeros. If I have, okay, let's say 3 zeros, 0, 0, 0. Can you see that? If I have 9 zeros, 0, 0, 0, 0, 0. If I have 100 zeros, I can have 1,000 zeros. Can you see that? Good. Can you go to 1 million zeros? Ah, it was too much. So you just put it that way for you. So this is 100,000, the same thing. 10,000, the same thing. 1,000. Okay. Anyways, so those are the zeros, right? So you can put them in that word form. Okay. Now, if I have, so for example, if I have maybe 3 like this. So if I have np dot zeros, right? 3, 3. See, I don't understand what you are saying. 3, 3, which means that these are our zeros. So this is the function, right? So I have to put it inside another bracket again. 3, 3. Can you see it now? So this is what now? This is what?
A matrix.
It's a matrix. Can you see that? So that array now is what it sees as what? The matrix. Okay, so that's why you can have it again. np dot zeros. Maybe I can have, let's say, 5, 20. Sorry. This is the bracket again. EO pass, what does this mean? What does this error mean?
I don't know, but you're missing one bracket.
Error function.
You have to close what that bracket. So when I say error while passing. Okay. So these are different ways of what putting. So you can have for zeros. You can also have np dot ones. So let's say, let me put 3 here. Can I see 1, 1, 1? But if I have np dot ones, 3, 3. Can you see that now? np dot ones, let's say 10, 5. You see that? So you can have that for what? The numbers. Okay. Another thing again we can also do. So I've showed you for zeros, I've shown you for 1. There's another one for identity matrix. What we have is called I. np dot I. np dot what? I. So if I have 3 like this, can you see that? MP.I. So if I have MP.I and I'm put, let's say 20. So in all the diagonals, it should be what? 1. Although this is too big though, but okay, let's say 9. At least 9 we can get that one here. The diagonals. So this is what this matrix is called what? This matrix is called what?
Identity.
An identity what matrix. Okay, an identity what matrix. Now, so we have looked at 0, we have looked at 9, we have looked at identity, right? So sometimes what we work with is usually numbers, isn't it? We usually work with what? Numbers. So we, in Excel, how we generate numbers now, isn't it? Random numbers, right? How we generate
Run between.
round between, exactly. So that is the same way you also have it here in Python, but in this case, this is called random. So I have to bring the library called random. So we say import random. Can you see that? Import what? Random. So if I have random.random, this one simply means generate any what random number. So this is your rand in Excel. Rand in Excel. Okay. But if I want to generate a number, then I have to say random dot what? Rand int. Rand int is what? Maybe it's integers, but you have to now specify. Now, do you see what's happening here? What's the error there? What's the error there?
Arguments between.
Yes. So they have written their own function. They have written their own function. They have written their own function. This is the library, this is the function, isn't it? Now, in this case, it must have 2 arguments. So, for example, I say, let's say which one? So, run between numbers, 2 numbers between 0 and what? 20. You know, so you know how round between is in Excel. So this is like a round between. This is your round. So round between 2 numbers. Okay, round between what? 2 numbers. Okay. So when we come again next week, we shall continue from there. How to now fill in numbers here with random numbers. So we can now be thinking about it like a normal routine. But go and practice what we have done so far, and practice your what? And just practice all this one we have done here. Because we are going to build from here. Then go and revise matrix. Go and revise what? A matrix. Okay. I have to go into another session now. So hopefully next week we'll come again.
Thank you, Dr. Francis.
All right.
Okay, sir. Thank you, sir.
All right. Take care.
Thank you, sir. Choose your time.